So we have some problems with solving linear systems graphically. If we're doing this by hand, we know that it can be time consuming. And even with our technology, sometimes it does take a bit of time to actually type in the equations and then find the point of intersection. With finding the point of intersection, even with the technology, sometimes you have to really zoom in or zoom out a lot to get to the point of intersection. If you're graphing by pencil and paper, it might not land on an easy to read spot. So graphing, while the technology does help us, it's sometimes not the easiest method. So we're going to learn two methods for solving algebraically. One is called substitution, which we'll spend today and tomorrow on, and the other is through elimination. So we're going to solve the example that you did on the front side, instead of by graphing, by substitution. So what we're going to do, step number one would be to name our equations. I'm going to call that equation 1 and the second one equation number 2, and I always put circles around them so that it doesn't become a 41 and a 12 here, so that they look like names instead of actual numbers as part of the equation. Now the second step would be to solve one of the two equations for either x or y. Now we're lucky in this example because both of them are already solved for y. So that makes step number 2 easy because it's already done for us. I'm going to write steps over on the other side here. So step number 1 was to label the equations with 1 and 2. The second step, which we don't have to do here, would be to solve one of the two equations for either x or y. It doesn't matter which one. I always pick whichever one is the easiest to solve for. And the easiest one to solve for would have a coefficient of 1. Okay, solve one of the two equations for x, either x or for y. So both of our equations here are solved for y. The third step would be to take the equation that is solved for either the x or the y, and we're going to do a substitution. We're going to replace the variable in the other equation with what we found it equal to be. So let me explain with this example here. So let's say I'm going to take first equation. I have it solved for y. I know that y is equal to 2x take away 4. And at the point of intersection, this y value and this y value down here are the same. So what I can say is I'm going to sub, short for substitute, equation 1 into equation 2. So where I have y in equation 2, I'm going to replace it with 2x take away 4. So my new equation would be 2x take away 4, so my y became that from the first equation, will equal negative 4x plus 1. And now this equation only has one variable in it, so we're going to solve for the x. I'm going to add 4x to both sides to undo that, the minus 4x, so we get 6x minus 4 equals 1. Then I'm going to add 4 to both sides to undo the minus 4. So I get 6x equals 5. And then to undo the times by 6, I divide both sides by 6, and x equals 5 over 6. And there is my x coordinate for my point of intersection. So let me just write step number 3 in there. We're going to substitute the expression for the solved variable for that variable in the other equation. And then we solved for the remaining variable. So we subbed in an expression, the 2x minus 4, for the y, and then we solved for the other variable, the x. Once you get that value, it's another substitution. You're going to take the value you solved, so we got x equals 5, 6, we're going to sub that back into the first equation. Substitute that value back into the first equation and solve for the other variable. Lastly, state the solution. So what we have here, I have x equals 5, 6. I'm going to sub x equals 5, 6 back into the equation I started with. So first I subbed equation 1 into 2. Now I'm going to sub this back into equation 1. So these numbers here should be opposite numbers. One's a 2, the other one's a 1. So I would have y equals 2. So from my equation, my 2 is multiplying my x. Multiplies 5 sixths. Take away 4. If I multiply those fractions together, I get 10 over 6. Take away 4. 10 over 6 is the same as 5 over 3 in lowest terms. I'm going to get a common denominator here. 5 thirds, take away 12 thirds, and 5 take away 12 is negative 7 thirds. So therefore, my last part, stating the solution or point of intersection is, x comes before y. I'm going to put my 5 sixths first, and the y comes second, the minus 7 thirds. Any questions? Oh wait, that doesn't work here. Question number 5, solved by substitution. I've got number 1 and number 2. Now I notice that equation 2 already has been solved for x. I've got an x equals this expression. So right away, I don't have to worry about solving. I'm going to sub equation 2 into equation 1. So where I have x in equation 1, I'm going to replace it with this expression involving y. So I'm going to have 5 minus 2y. There's the x. So my original equation was this. So I've replaced the x with that. Plus 3y equals 1. Negative 2y plus 1y, or 3y's equals 1y. So I have 5 plus y equals 1. I can subtract 5. And y equals negative 4. Now that I have what y is equal to, I can sub that back into my equation 2, the other equation that I am subbing in. Sub y equals negative 4 into 2. And my equation 2 was x equals 5 take away 2 times y, which is negative 4. 5 take away, that will end up being a plus 8. And 8 plus 5 is 13. So my solution, therefore, the solution is x comes before y. The x was 13. The y was negative 4. So even though I found negative 4 first, it's the y. It goes second. And this is my x value here. So it comes, the 13 comes first. All right, the last example. Neither of these equations, so first step, label equation 1 and equation 2. Neither of these equations is solved for x or y. What I do is I look for a coefficient of 1, so a number in front of my variable of 1, which is right here. That one's going to be the easiest one to solve for. I'm going to solve equation 1 for x, get x by itself. So I'm going to subtract 3y, and I get x equals 2 minus 3y. So I'm going to call that 1b. Okay, because it's really equation 1, it's just a variation of 1. And then I'm going to sub, and I can either write 1b or I could say x equals 2 minus 3y. It's your choice how you want to write that. Into the other equation. It has to go into 2, so I'm going to replace the x with 2 minus 3y. So I'm going to have 2 times 2 minus 3y plus 5y equals 3. Multiply through the bracket. We get 4 minus 6y plus 5y equals 3. I'm going to collect these. That's a minus y. I still have my 4. And then I'm going to actually add y and subtract 3. I do that all in one step because I'm running out of room. So 4 take away 3 would just be a 1, and I would have y left here. And then I'm going to sub y equals 1 into my other equation. So it was 2 here, I'm going to put it into 1, and I can go into my 1b here, and I get x equals 2 minus 3 times the y value, which is 1, 2 minus 3, which is negative 1. So finally I have the solution is x comes before y, negative 1, 1. I hope you enjoyed this.